Okay, here we go. Differentiate the following. First thing I need to look up is the tan inverse rule, okay? So will somebody look up the tan inverse rule that's in your tables? So you have y equals tan inverse x over a, and then we get to y dx equals a squared. A over a squared plus x squared. Alright. What I always know is a equals 1, guaranteed. What I also know to do is an adjustment. Anywhere I see the x, I now put in a box of what I have. I don't have x. What's in the box is x over 3. Sorry, x over 3. And then I also have to differentiate the box at the end. So here's what happens. I've identified it as a tan inverse. I looked up the generic formula. I modified the generic formula to have in what I need. Okay? Now, the y dx equals a is 1 squared plus x over 3 squared, differentiate x over 3. What happens when you differentiate x over 3? 1 over 3. Now what we're going to get is 1 over, now see this x over 3 squared, that changes into x squared over 9. Okay? You need a common denominator, so it's going to be 9 plus x squared all over 9. Does anybody need me to explain that step? I put them both over 9, didn't I? And then just add them together. 1/3. Now, this fraction here, I bring it to the top and turn it upside down. So when I bring it to the top and turn it upside down, it's going to be 9 over 9 plus x squared. It's now at the same level as the third. And then cancel. 3 over 9 plus x squared. That's the first answer there. Okay? Alright lads, now that's done, okay? What we're going to do next is we're going to do x equals sine inverse x. Now, rationale here is if this was on its own, it'd be its own question. Okay? Now, pay specific attention to what I'm about to tell you. Y equals, if I had this, alright, and I had to differentiate it once or twice, the x would differentiate on its own to 1. Then I would differentiate sine inverse x into, what's the rule for sine inverse x? It's 1 over square root of a squared minus x squared. Is that correct? And then that would be 1 over a squared minus x squared. So it would be 1 over the square root of 1 squared minus x squared. And then you could say it's 1 divided by 1 over 1 minus x squared to the power of a half. And then you could bring it up. You could do the quotient rule there. If you had to differentiate a second time, it'd be the quotient rule and the 1 would turn to a 0. And you could do the quotient rule, or you could do the chain rule and differentiate out. But unfortunately for us, this is not the question we're being asked. So the question we're being asked is not an addition question, it's a multiplication question. You need to know the difference between the two. Just the presence of a plus, basically, okay? So now that that's done, what you're going to do next is you're going to differentiate the product rule, okay? So it's a product rule because it's multiplication. You write down y equals uv, then you're going to write down what the y dx is. The y dx equals u times the v dx plus v times the u dx, and that's it. U equals x, the u dx equals 1, v equals sine inverse x. Now because it's the generic, what I mean is it's not a third x, it's not 3x, it's the standard equation. What we can just do is just take it right from the notes. Please have your tables in them tomorrow. There goes. A is 1, so it's going to be 1 over the square root of 1 minus x squared, or 1 squared minus x squared. Put it together, and we're going to get x times 1 over the square root of 1 minus x squared. And then the other one is going to be plus sine inverse x, and v times the u dx is 1. And that's our answer, guys. Our answer very simply works out as this: x over the square root of 1 minus x squared plus sine inverse x. It gets very interesting if you have to differentiate it a second time. Okay? Do you want me to differentiate it a second time? Yeah. Just for practice sake, I'll differentiate this a second time. So the question is officially done. because it only asked me for the first derivative, now it asks me for the second derivative. So what I'm going to do is I'm just going to take that out for a minute and put in power of a half on the bottom, right? Now, I identified this as two separate questions. Separate question in red, separate question in blue. Why did I do that? Because the plus in the middle. I identified the first one as a quotient rule, where u equals x, du dx equals 1, phi equals 1 minus x squared to the power of a half. Now, just because exercise 1 isn't in it, doesn't mean that exercise 1 is no longer in effect. A half goes to the front. What happens next?
Take one away from the power.
Take 1 away from the power. And finally, what else happens?
Differentiate the box.
Differentiate the box for your minus 2x. And then we're going to have minus x, because the 2's cancel. Bring that power back down to the bottom. 1 minus x squared to the power of a half. Now guys, look at this product rule then, okay? So it's there's a lot of information here, and this one is going to take a lot of space.
What would it be product?
Oh, sorry, quotient rule. Excuse me, quotient. Yeah, it's the formula I wrote down initially. It's a quotient rule. Okay, so I'll write down the quotient rule in the corner. It's going to be phi times du dx minus u times dv dx all over v squared. Okay, so you're looking at this, guys. Phi squared on the bottom. So and then phi, which is 1 minus x squared to the power of a half, du dx, which is 1 minus x times dv dx, which is going to be just better drag this down. Oh, sorry, the line isn't. I had to fit in a fraction there, so the line starting off the line wasn't a good idea. So it's going to be, what's it? Minus x over 1 minus x squared to the power of a half. Close that there. Okay. Now, what I'm getting here is 1 minus. What happens now is this, okay? 1 minus x. Sorry guys, 1 minus x to the power of a half. Okay. 1 minus x to the power of a half is what that part turns into. This part here turns into minus x by minus x is plus x squared over 1 minus x squared to the power of a half. All over. On the bottom it was 1 minus x squared to the power of a half. It's phi squared, isn't it? So it's the power of 2. What's a half to the power of 2? 1. Well done. You know your indices off by heart now, okay? Now guys, look at this now. If I need a common denominator. So I'm going to put a common denominator for the top below it. And what I multiply on the bottom, I also must multiply on the top. Now what do the two of these become? That's the x squared, by the way. Keep forgetting the x squared. Huh? 1 minus x squared plus x squared all over 1 minus x squared to the power of a half. Divide that again by 1 minus x squared. Now, the rule is you can bring this a fraction divided by a fraction. So, for example, 3/4 divided by 2. It's the same thing as 3/4 divided by 2 over 1, which is the same thing as 3/4 multiplied by 1 over 2. I'm going to flip this bottom part. So what I'm going to get is 1 over 1 minus x squared to the power of a half. And then on the top, I'm going to get 1 over 1 minus x squared to the power of 1. What's the power of 1 by a power of a half? Power of a half multiplied by a power of 1. So, for example, y to the power of 1 multiplied by y to the power of a half. 3.5 or 1.5 or 3 over 2. Hence, the answer to this one is going to be 3 over 2. Okay, guys. First derivative, easy. Second derivative, very complex. A lot of rules there. Alright, guys, moving on. Tan inverse x. Okay. Okay, so lads, what I've identified here is this as a product rule. Two distinct entities here, and also, please remember, it acts completely differently if it's a plus and not multiply. Are you happy with that? Now, What's going to happen here is I'm going to write down the which rule, product or quotient? Product rule. Okay? So right at the beginning, just write out the product rule directly from your tables. Now that that's done, okay, u equals e to the minus x squared. To u the x is what? Now, what's the golden rule for e to the x's? Their power never changes. What's the power? The power and the e will go right into the derivative right away. Only thing you need to worry about is the power. Differentiate the power. Minus 2x. That's you done. V equals sine x. Therefore, the v dx is cos x. So what we're going to get here is this, guys. We're going to get e to the minus x squared multiplied by the v dx, which is cos x, plus v times sine x minus 2x e to the minus x squared. Finish it off. Cos x e to the minus x squared. And then what's that going to be? It's going to be minus 2x sine x e to the minus x squared. Yeah, that's a pretty substantial question there. Okay, so
wait, so just see the du dx.
Yeah.
It's just minus 2x.
E to the minus x squared.
E to the minus x squared.
Yeah, because the e, it never disappears when you differentiate. Never changes. So guys, golden rule, when you differentiate e to the power of anything, provided that anything is a variable, has an x in it, it goes straight into the next part. Exactly the same, unchanged. Okay? So look at this one here, for instance, number 22. Although they're not x's, they're theta's, but you gotta treat them in the same way you would an x. This question could also look something like this. F of x equals e to the power 1 plus sine x. Now, it says I need the first derivative and the second derivative for this question. First derivative, okay? Now, the rule is, it goes in unchanged. Did you hear that? I put it in right away. Next part, what do we need to do then? Differentiate the power. So when I differentiate the power, what I'm going to get is, it's just going to be cos theta, isn't it? Okay, well done. And then what we're going to get is cos theta e to the 1 plus sine theta. Now you're at the second stage, which is the second derivative times theta. Second derivative times theta. What type of rule am I looking at here, guys? Sorry? And why is it a product rule? Two things multiplied by each other. So u equals cos theta. What's the u d theta then? Minus sine theta. What's phi? Sorry?
E1 plus sine theta.
What's the v d theta?
Is v not minus cos theta?
Oh, sorry, you're right. Shh, sorry guys, it is e to the 1 plus sine theta. Now, do you know the great thing is about this? You've already differentiated, haven't you? Look at the original question. You've already differentiated and you got the answer. Cos theta e to the 1 plus sine theta. You've already done it. So why do it again?
1 plus sine theta minus. It's not just sine theta because minus 1.
Because 1 disappears to 0. It's the same way we did the first one, Shane.
Yeah.
Remember, you take the power directly down. You take the full thing directly down. Yeah. Differentiate the power. And you differentiate the power, 1 turns to 0, and sine theta turns to cos theta.
Yeah, but cos theta and then e power of
1 plus sine theta.
No, this is sine theta because it's minus 1. You get minus 1 from the power and you differentiate.
Oh, I haven't got there with the. I haven't put in the limit yet. Is that what you're asking me?
Yeah. No, I was saying.
Alright, guys. So, what I get here is this, okay? It's going to be u, which is cos theta, times the u dx, and what's the u? Oh, sorry, times the v dx, which is cos theta, e to the 1 plus sine theta. Okay, I've used that part there already. And then what's phi? Phi is going to be get rid of u and get rid of the v d theta. So the next part is going to be plus v, which is e to the 1 plus sine theta. times minus sine theta. That's being multiplied, by the way, not subtracted. Now, what happens here is I get the following. I'm going to get cos squared theta e to the 1 plus sine theta, and then I'm going to get minus sine theta e to the 1 plus sine theta. Now guys, look at this. Now, I don't have to factorize it out or anything like that. I could do. You're right. Sean said if this was a proved question, I could take this part and this part out of the brackets and do that. But I don't actually have to do it, because all it asked me to do is replace all the, for the first derivative, replace all thetas with 0. What's cos 0? 1. What's sine 0? 0. It's 1 e to the power 1, which is e. What about the next one? What's cos 0 again? 1. Oh, sorry, yeah, right. I did that last time as well. It's actually pi over 2 this time. So, I actually did that last time. Just assumed it's the same thing. Alright, guys. Pi over 2 is 90 degrees. So, here's the interesting one, alright? Pi over 2 is 90 degrees. What's cos 90 degrees? I can tell you now it's 0. This full thing turns to 0. What's sine 90 degrees? 1. And then what's 1 plus sine 90 is 1 plus 1 e squared minus 1 e squared. Okay? Okay guys, 2 hard questions coming up here. To begin with, you need to look for the generic. The generic is this. ln x dy dx equals 1 over x. Once you have the generic down, you then do the modification. ln box equals 1 over box, differentiate the box. So for example, 17 is ln sine x to the power of a half. Now there's a quick way of doing it. The quick way is using the log power rule. Should anybody remember the log power rule?
Log E.
Sorry, this one here. Log 100 is the same thing as log 10 squared. Bring the 2 to the front. Same thing as 2 log 10. It's a much quicker way of doing it. But you don't necessarily have to do it that way. So look, I'm going to argue that a lot of you guys aren't going to remember the tricks. So we're just going to have to bash through it the hard way. Okay? So you could do it that way. And what you'd be differentiating instead would be a half ln sine x, which is a much quicker procedure, because all you're going to do is you're going to get dy dx. What happens when you have a number at the front but the number doesn't have a variable?
0.
It goes straight down, and then you just differentiate the second part. An example would be if I had 3x squared. What you often tell me is that the number goes straight down. You differentiate the second part, which will be 2x, and the answer to that is 6x. So you actually do it all the time, you just don't realise you do it. Okay? So what happens here is it was a half plus ln, it would disappear. But because it's being multiplied, it goes directly down. Now guys, look at this. 1 over sine x, yeah? And then differentiate the box, differentiate sine x, and we get? Sorry, plus cos x, you're right. And that's going to be a half 1 cos x over 2 sine x. Now, that rule made things so much faster. But look what happens when you don't spot the rule. When you don't spot the rule, you're going to have to do it this way. Y equals, that's, y is going to equal, sorry, dy dx is going to equal 1 over the box. That's the box there. So 1 over sine x to the power of a half. Differentiate the box. If we're differentiating this box, what we can say is, what type of rule is differentiating this box? It's a chain. It's going to be a half. The chain never changes, but the power does. Minus a half. And what's differentiation of sine x? Cos x. So it's going to be a half sine x to the power of minus a half, and then cos x on top. Now look what happens here, guys. We change this part here to what? It's a negative power. What have we been doing with negative powers repeatedly? Bringing it down. So I'm going to move the 2 to the front because it's multiplied. And then we're going to have sine x to the power of a half here again. All over 1 cos x. Now what's sine x to the power of a half by sine x to the power of a half? So 2 sine x on the bottom and cos x on the top. Now guys, likewise, if you remember that power of a half rule, look how easy you can make the next question. I did it the hard way with you, so if you look up the video, I most definitely did 18 the long way. But what I'm going to show you is how to do 18 the short way. Yes, right? Yeah. Alright guys, look at 18 the short way, okay? Y equals ln, the whole thing to the power of what? A half. Here's the short way. Bring the half to the front. A half. Ln x plus 1 plus x to the power of a half. Sorry, the half's gone. Now, if you do it this way, you make the quotient rule, because you're going to have to differentiate what's in the box, remember. Dy dx, what happens to the half, guys? Straight down. And then we got to differentiate everything that's in here. It's 1 divided by the green box. So it's going to be 1 divided by x over 1 plus x. While we're here, what's 1 divided by a fraction? Bring the fraction up and turn it upside down. So why don't we just do that to begin with? Make the whole process a lot easier. So we're just going to put the 1 plus x to the top. Is that alright? Yeah. Now that we've established that, we now have to differentiate what's in the box. What type of rule is in the box for differentiating it? Quotient rule. Okay? Du dx equals 1, u equals x, phi equals 1 plus x, dv dx equals 1. So we're going to get phi times du dx, which is 1 plus x times, multiplied by 1, minus u times dv dx, which is x times 1, all over 1 plus x squared. Now look what happens here, guys. 1 plus x minus x cancels, and we get 1 over 1 plus x squared. Now guys, look at this now. That's the red part at the end. Now, can anything cancel anything here? What can cancel? Sorry? Okay, the 1 plus x with this one here, and we're going to get 1 over 2x bracket 1 plus x. The previous way I showed you was much longer and much more. If I gave you one like this, and what I want you to do is get the y dx, no specific form at the moment, okay? Then divide it as what type of rule? Quotients. What's the u dx? 0 plus 2 e to the 2x. V is 1 minus e to the 2x. What's the v dx? Minus 2 e to 2x. Perfect. Well done. That's good. Good work there. Quotient rule. Everybody knows the quotient rule off by heart by now? Okay. Look it up every time. Just make sure you don't give a mistake out. 1 minus e to the 2x. 1 minus e to the 2x. 2 e to the 2x minus phi times du dx. Oh, sorry, that's plus. Wait. Getting this mixed up now.
No, that's right.
That is right. Yeah. 1 plus e to the 2x multiplied by minus 2 e to the 2x. All what's going on here then? It's going to be 1 minus e to the 2x squared. Now look at this, guys. Multiply it out, e to the 2x. Now, what's e to the 2x multiplied by e to the 2x? You add the powers. For example, e to the 2 by e to the 2 is e to the 4. E to the 4 by e to the 6 is e to the 10. Add them together. So we're going to get minus 2 e to the 4x. Then we're going to get, this is going to change that one with that one because we're multiplying minus by minus. And then we're going to get plus 2 e to the 2x. Plus 2 e to the, those two cancel. And what we're going to get is 4 e to the 2x, all divided by 1 minus e to the 2x squared. Okay, guys.